In this video, we want to solve 20 problems of IMONST for Malaysia Mathematical Olympiad. And there are 20 problems, all of them for junior, 10 of them for primary, 10 of them for senior. We want to solve them. Please subscribe my YouTube channel now and turn on notification to have next videos and like my video. And I will release the other problems and other solutions of senior and primary in my next videos. If you had any question or wanted the answers of senior or primary, feel free to send message to my WhatsApp number in the description and comments. Okay. Problem, the order is not same, and after that the official website will release all the problems. I will release the solution in the same order, so maybe this order is not same for you. So you can check all the videos and find your questions. Okay, question number 1. You can check, for example, this question is what question of your paper, and if you had any question about the order, anything, as I said, feel free to send message to my WhatsApp number. Question number 1. My school's chess club invited another school's chess club to practice together. Each player from my school played against 4 different players from the other school. So we have 4 different players. It is my school, 4 different players. 4 different players. Okay, and the last one, 4 different players. While each player from the other school played against 3 different players from my school. So this one, we can say it is my school, and this one is other school. My school, other school. Now, let's read the rest. If my school had 12 players, 1, 2 to 12, how many players did the other school have? So, suppose the other school have 1 to n, 1, 2, 3. So if we want to calculate the line between these two parts, from this part I can say 12 times 4, the number of games, number of games. So equals what? This one. Each of them played 3, so it will be 3n. And okay, so if you divide both sides by 3, it will be 4, so n will be 16. So the answer of this problem is 16. Okay, question number 2. As I said, the order maybe is different. You can check this question too. Is what question of you? If you had questions, feel free to send message to my WhatsApp number in the description and comments. For a positive integer n, we denote by d of n the number of distinct positive divisors of n, and by s of n the sum of these divisors. For example, d of 2022 is 8, since 2022 has 8 distinct divisors: 1, 2, 3, 6, 3, 3, 7, 6, 7, 4, 10, 11, and 20, 22. As a result, S of 2022 is 1 plus 2 plus 3 plus 6, this. Determine the largest positive integer n such that Sn times Dn is 96. Okay, so Sn times Dn equals 96. So because there are 2 factors of 96, I prime factorize that. It's 2 times 48, and you can say it's 3 times 32. So we know S of n is at least D of n. Why? Because if you check, you can say S of n sum of divisor, it is number of divisor. Each divisor is at least 1, so we can say sum of them is at least D of n. For example, look here, we have 8 divisors. Each of them is at least 1, so S of them is at least 8. Now, for this problem we don't need, but for other problems, S of n and D of n has formulas, and I work with my students in my classes. If you want to know the formula of S of n and D of n, maybe in other exam or other round of IMONST is useful, or other Olympiads, feel free to send message to my WhatsApp number in the description and comments. So Sn is greater than that. So if I check, 96 has how many divisors? If you check, it is 3, 2 to the 5. So here we can say 6 times 2, 12. 12 divisor it had. The formula is power of this 1 plus 1 times 5 plus 1, 6, 12. Okay, so if Sn is 96 and it is 1, then we have one divisor and sum of them is 96. So if you have one divisor, the only number, positive number that has one divisor is 1, so contradiction for this part. If it is 48, we want to start from greatest number Sn. It is 48, it is 2, the divisor, so it is a prime number. And the divisor are 1 and p, and 1 plus p is 48. So in this case, p or n is 47. Now let's check to see, can we find any better number after 48, the maximum number? 3 times 16, 3 times 8, 32. If it is 32, 3, now we know the number of divisors is at least 3. And then we can say, okay, sum of divisors, also one divisor is n plus something, n plus 1 plus something is 32. So for all other cases, we can say n is at most 31. So we can say it is the best number. And because it says find the maximum largest positive integer n, so the answer of this problem will be 47. Okay. In my order, let's solve problem question number 3. The champion of a cycling competition took 51 minutes to run the 13-kilometer track. Lim took 1 hour and 18 minutes if Lim and the champion. Okay, here says they cycled with constant speed. What was Lim's distance from the crossing line in meters when the champion crossed the finishing line? Okay, so let's suppose it is the crossing line. And okay, so let me draw, for example, suppose it is starting line, finishing line. The distance is 13 kilometers, and it says in 51 minutes it passed from this one, the champion. We know the speed is v is distance over time. Okay, so after 13 kilometers, it says the champion crossed the finishing line. So after 51 minutes, we want to see after 51 minutes, Lim, the distance of Lim from crossing line. Okay, so we should find, because we know the time, 51 minutes, we should find the speed of Lim. Speed of Lim is what? V of L is distance 13 kilometers over the time. Let me find kilometer per minute. It will be 1 hour and 78 and 18 minutes. It will be 78 minutes. And then we can say, okay, now I want to find the distance that Lim has passed. So distance of L is like this. V of L times T. T is what? 51 minutes. So it will be 13 over 78 times T. T is 51 minutes, but it is in kilometers. So we want to find it in meters. So we multiply it by 1000. So here, if we simplify the, okay, it is 4 times 17, it is 3 times 17. So if you divide both by 17, it will be 4. And then divide by 4, it will be 250. And then if we multiply, it will be 39 times 250. And if we multiply 39 by 2, 5, 5, 9, 45, 4, it will be 19. 2 times 9, 18. We have 1, 6, 7. It will be 5. It will be 7, 8, 9. Oh, sorry. Here it's 4 times 17 is 68. So here let's correct this part. So if we divide, it will be, let me correct this. Here we can say, okay, it is 6 times 13, it will be 6. If you divide by 3, it will be 17. And if you divide by 2, it will be 500. So if we calculate these two things, 5 times 17 is 85. So it will be 8,500 meters. So here, if we calculate the distance from starting line and the distance from finishing line, here it will be 8,500 meters, and this part, the all pass is 13,000 minus 8,500, which is what? Which is 4,500. So this distance is, so we found the distance of this point from both starting line and finishing line. Okay, problem number 4 in the order of my PDF. We want to choose 3 positive integers a, b, and c, satisfying both these conditions. A is less than b, less than c, less than 2022, b equals a plus c over 2. How many ways are there to do it? Okay, here look, because b is a plus c over 2, the parity of a and c should be same. Means what? A and c, both of them are even numbers or both of them are odd numbers. And then if you select two, for example, odd numbers, 1, 3, 5, 7, to the last odd number is what? 2021. If you select any two, then b will be unique and will be determined. For example, 1, 3, b will be 2. 1 plus 3 from this condition. 4 over 2, 2. 1 and 5. 1 plus 5 over 2, b will be satisfied, will be fine, determined. And we want to find the number of ways we can select. So well, a and c are odd, 1 to 2021, or even. And there are positive integers, so 2, 4, 6, 8 to 2020, because it is strictly less than 2022. Here, if we want to select for this part, how many numbers do we have? 10, 10. Choose 2. You should select 2 numbers. And this one, it will be 2022 over 2 will be 10, 11. Choose 2. And if we calculate, we should calculate both each of them. The first one is it will be 10, 11 times 10, 10 over 2. And this one will be 10, 10 times 10, 1009 over 2. And if we add up these two things, we should add, because we can consider this one or this one. If we add up, it will be 10, 10 times 10, 11 plus 1009, it will be 20, 20 all over 2. And if we divide, it will be 10, 10. So the answer is 10, 10 squared. So if I multiply 101 times 101, it will be 101, and 101 here, 10201. So here, okay, so the answer is equal to this. Okay, in the order of my PDF, question number 5, let ABCD be a convex quadrilateral such that, let me draw it. Okay, ABD is what? Is 20. Let me minimize it. Okay, it's 20. DBC is what? DBC is 60. ACB is 50. ACD is 10. Find ADB. So let me call ADB X. We want to find X in degrees. 50 and 10 is 60. 60, so this angle should be 60. So DBC is an equilateral triangle. This one. And now we can say it's 20, 60, 80. 50, 80 plus 50 is 130. So this angle will be what? 50. And now, because it is an isosceles triangle, this side equals this side. So here we will see all these angles are equal, so we understand ABD is an isosceles triangle. So because we want to find x, we understand that also it is x. So x plus 20 is 180. So we can say 2x plus 20 equals 180. So we divide both sides by 2. X plus 10 is 90. So x is 80. So 80 degrees. The answer of this problem is 80 degrees. Okay, in the order of my PDF, problem number 6, as it writes down in order all positive integers which are divisible by 2. Betty writes down in order all positive integers which are divisible by 3. So the first one, as is, writes down multiples of 2, positive integers 2, 4, 6, 8, so on. Let me Consider B is Betty, multiples of 3, 3, 6, 9, 12, and so on. And Chan writes down in order all positive integers which are divisible by 4. 4, 8, 12. We see all these numbers also here because multiples of 2 devil. Then writes all numbers written by the other 3 in increasing order. Okay, so devil then writes all numbers written by the other 3 in increasing order. Means what? Without repetition. What is 22nd number in devil's list? So the first number is 2, the second number is 3, the next number 4. We don't have 5, 6, 7, we don't have 8, 9 here, we have 10 and 11, we don't have 12, 13, 14, 15. Okay, like this, and we want to find 20, 20, 20, 22nd of them. And then we can say what? We can say here, we can say, because multiples of 4 are multiple of 2, we can say there are multiples of 3 and 4. Of 2 and 3. So here, I want to see, for example, if I have a number n here, I want to say, okay, n, if n is 6k, n here, we want to say how many numbers until n I write. For example, suppose n is 6k. So I write n over 2 numbers, and because we can consider floor, but because it is multiple of 2, it's okay. Plus n over 3 numbers until here. Minus because we count multiple of 6 twice. Look, you say, for example, 2, 4, 6, 8, 10, 12, 14. And for multiples of 3, you say, okay, 3, 6, 9, 12, 15. As you can see, multiples of 6, we count them twice. So n over 2 plus n over 3 minus n over 6. We want to say it will be what? 6k over 2, 3k, 6k over 3 plus 2k minus 6k over 6 minus k. It will be k plus 3k, 4k. We want to find k that is nearest to this. It is multiple of 2020 is multiple of 4. 2020 over 4 is what? Is 5 times 4, 20, 0, 5. So if we consider 6 times this number, 6 times 5, 0, 5, 30, we have 3 and 30. So if we consider this number, until here, we've written how many numbers? 20 numbers. Now we should write next two numbers. Let me write with green. With green, it is multiple of 6. The next number I write is 30. 31 is not possible. 2, because 31 is not multiple of 2 and it's not multiple of 3. And the next number is 33. So the answer of this problem is this, 33. Question number 7. Determine the largest 3-digit number which satisfies the following conditions. It is a prime number. The number obtained by reversing its digits is also prime. The product of the digits is the number is also a prime number. So let's focus at first the third condition. The product of the digit is also in the number is also a prime. So we should have 1 and a prime number p. That p is 1-digit number. Because it says find the largest, so if we consider 9, it will be 911. It's the greatest possible case we can have, but the reverse will be what? 119. And this number is multiple of 7, 7 times 70, so it is bad. If we consider, so this digit, maximum 9, was impossible for 7. 7, 11, and it will be 117. But this number is again not prime because it's multiple of 3. The next one, 511115, it is again bad because multiple, the reverse is multiple of 5. And next one is 311113. If we check these, two numbers, it is not there are not multiple of 3. For this number, you should check divisibility. 3, 5, 7 until the square of this. 11, 13, 15, 17, 19, until 17 is enough. For this one, you need to check 3, 5, 7, only these numbers. And we see it is prime. So the maximum number, the answer of this problem is 311. In the order of my PDF, question number 8. And Alia wants to complete the following sequence of numbers such that the difference between every pair of adjacent number is 1, 3, 5. How many ways are there to fill in the blanks with the numbers 2, 3, 4, 5, 6, each appearing exactly once? So because the difference is 1, 3, 5, so it should be even, and any even is okay. 2, 4, 6, and if you pay attention, the next one should be odd, and because there are 1 to 6 the numbers, the difference, even and odd, can be 1, 3, or 5. So it is even, it is odd, it is even, it is odd, it is even. So you can place any even numbers in these even places and any odd number here in the odd places, because each appearing exactly once. So you can say, okay, for 2, 4, 6, you have 3 factorial to place them, and for 3 and 5, you have 2 ways to place. So 3 factorial, 6 times 2, 12. Okay, if you had any question about the solution of this problem or other problems, because they have, each problem needs some ideas, factorial, something like that. If you have any question, feel free to send message to my WhatsApp number in the description and comments. Question number 9. Consider the following shape consisting of 5 triangles all meeting the common vertex in the middle here. 5 triangles, 1, 2, 3, 4, 5, and this vertex in the middle. Starting at the middle, how many paths can we use to draw this shape with a pen without lifting the pen and without repeating any edge? So for each triangle, we can say, okay, if we start, we can go with this way. Let me write with this way, like here, for example, clockwise or counterclockwise. And we have how many triangles? 1, 2, 3, 4, 5. So we should select and the order that we want to go to these triangles. They have 5 factorial for orders. Which of them first? For example, 3, the next one 2, the next one 5. And when we select each of them, for example, we want to start with 3 clockwise or counterclockwise. So 2 for each of them, 2 times 2 times 2, 2 to the power of 5. And if we calculate, 5 factorial is 120 and 2 to the 5 is 32. And if we multiply these two numbers, it will be 64, 32, and it will be 483. So 384. Okay, in the order of my PDF, question number 10, the area of the intersection of a smaller and larger square equals 5 over 6 of the area of the smaller square, as well as 1 over 11 of the area of their union. Determine the ratio of the perimeter of the largest square to the smaller square. Okay, so here we consider, for example, it is our first square. Their intersection we consider like this, and it is not important. You can also consider them like circle. I don't want to use this. I want to only say, okay, they have intersection. It is not important. It is in this shape or this shape. Without loss of generality, we can consider this. So it says the area of intersection is 5 over 6 of So consider, for example, this side is A, this side is B. So this intersection, let me call, for example, this area T. So T is what is, let me write it with big letter. So T is what? T is 5 over 6 of the area of a smaller square, B squared, as well as 1 over 11 of the area of their union. Area of their union is what? You can say, okay, because it is T, you can, and T is 5 over 6 B squared, so you can say A minus 5 over 6 B squared, because it is 5 equals 5 over 6 B squared, and this one will be what? 5 over 6 B squared, so the area of the whole part is B squared, so you can say B squared minus 5 over 6 B squared it will be 6b squared minus 5b squared b squared over 6. So here it will be b squared over 6. And then it says, okay, 5 over 6b squared is 1 over 11 of the area of their union. Their union will be what? Here it's b squared plus. This one will be a minus 5 over 6. Oh, sorry, it's a squared. A squared because the area is a squared minus 5 over 6 b squared. And we have this, and the problem says determine the ratio of the perimeter of the larger square. So perimeter of larger square is 4a, a plus a plus a. Four sides, each of them is a over smaller square, which is a over, let me check, ratio of perimeter. Oh, yes, a over b, larger is a. Now here we want to use this, it's b squared. Okay, this one, let's solve this one. 5 over 6 b squared is this. So if I want to consider b squared, I say, okay, 5 over 6 I have here, minus 1 over 11, and this one is minus, if you take it to left hand side, it will be plus 5 over 66. B squared equals a squared over 11. And here you can say b squared, you can multiply both sides by 66. It will be 55 because 11 minus 6 plus 5 equals 66. It will be 6a squared. 55 plus 5, 60 minus 6, 54. So we can say a squared over b squared is 54 over 6, which is 9. So a over b is what? Is 3. In the order of my PDF question number 11, let n be a positive integer. Vertices of a regular two-n-gon are painted red and blue in an alternating fashion. All the sides and diagonals of the two-n-gon are drawn. If the number of segments in the diagram with ends of the same color is 1122, find the number of segments with ends of different colors. Okay, so, and let's consider, for example, we have two-n-gon like this. Okay, so you say it is 1, 2, 3, 4, 2n, 2n minus 1, 2n minus 2, this one. If we consider, for example, it says red and blue. Okay, so let me consider red, this point, this point, this point, this point, this point, and blue. There are blue points. Okay, so all the sides and diagonals of the disc are drawn. Okay, if the number of segments in the diagram with ends of the same color. Same color means what? How many same colors do we have? N. So you say n choose 2 n red colors plus n choose 2 blue colors is equal to 1122. So you can say it is n times n minus 1 over 2 plus n times n minus 1 over 2 equals this. If you multiply both sides by, no. If you add these two things, it will be n times n minus 1 equals 1122. So we should prime factorize to find n. It is what? 2 times 5 times 2. Then we have what? We have 1, 12. It will be 6. 5, 6, 1. Then it is multiple of 3. You can say, okay, 2, 3 times 1, 3, 26, 8, 21, 7. And then we can say it's multiple of 11. Yes. 2, 3. If you divide it by 11, it will be 1, 7. Now we want to find two consecutive numbers. 2, 22. No. If we consider 2 times 17, 34. 3 times 11, 33. So we conclude that n is 34. Now the problem says what? The problem says find the number of segments with ends of different colors. So n is 34. You have n red points. 34 and times 34 blue points. So this is the answer. 34 is 2 times 7. You can say 4 times 17 squared, 289. You can calculate it any way you want. 4 times 9, 36. We have 3. 4 times 8, 32. 35, 3. 4 times 2, 8, 11. Question number 12. A positive integer written only with digits 1 and 2 is called nice. Therefore, the first few nice numbers are 1, 2, 11, 1, 2, 12, 21, 22. Determine the 60th nice number. Okay, if you want to find 60th nice number, we say, okay, if we have one digit, we have only one or two. So two digits. It's one or two. If we have two digits, each of them 2 times 2. The first digit 2 times 2, 4. Because each of them is 1 or 2, 1 or 2. And if you write 1, 1, 1, 2, 2, 1, 2, 2. So 2 here, 4 here. We should continue. So you say 2 for one digit numbers. 2 squared for two digit numbers. We should continue. Because 2 plus 4 is 6. Plus 2 cubed for three digit numbers. And some of them will be 8 plus 4, 14, plus 2 to the 4, 30, plus 2 to the 5, it will be 62. So, if we want to find the last number is consider 5 digits. 2, 2, 2, 2, 5 twos, it is what? 62nd number, because here we've calculated 62. And the previous number is what? So we have 5 twos, so it will be 2, 2, 2, 2, 2, 2, 3, 4, 5. And the previous one is, okay, we can't change, we should consider this one. We have 4 twos, 2, 3, 4, and you change it to 1, and the next one is 2, so here. Okay, so 60th one is, because some of them look 2, if you add 2, it will be 4, 8, and 64. It will be 62, and here 62. So 60th number is 22, 22, 12. Question number 13, ABCD geometric problem. Let me draw it. Okay, here ABCD is cyclic. It is ABCD. Cyclic quadrilateral whose diagonals are perpendicular to each other, and one of the diagonals is the diameter of this circle, this diagonal, and the area and the perimeter of the quadrilateral ABCD are 48 centimeters squared and 28 centimeters respectively. Find the radius of the circle in centimeter. Okay, so if we want to solve this problem, we can say what here, because it is radius, we can say it is lies on perpendicular bisector of this part. And you can prove that this is x. It is x because it is isosceles triangle, because this line is perpendicular, and also angle median. How we can say it bisects? It's a theorem. There are around 50 important formulas and theorems in geometry. If you want to know them, feel free to send message to my WhatsApp number in the description and comments. It is x, x, y, y. Then we can say what? It is O. And the area is what? Area is 48. So x, y over 2 for this triangle. Why? Because it is 90, because it is the diameter here. It is 90. So the area of here is xy over 2. The area of here is xy over 2. Sum of them area ABCD, which is 48 centimeters squared, and the perimeter. Perimeter is 2x plus 2y equals what? 28. So we conclude what? Xy equals 48 and x plus y is 14. The problem wants what? Find the radius here. You can check what xy satisfy, or you can replace and solve quadratic formula. But if you check, for example, if you place 6, 8, it works. For example, x is 8, y is 6. It satisfies both of the equations. So AC, by Pythagorean theorem, we can say AC squared is 6x squared, 8 squared, or x squared plus 6 squared, which is 64 plus 36, which is 100. So we conclude AC is 10. So AC is what? Is diameter. So radius is half of that, so the answer is 5. Question number 14. For any positive integer n, the factorial n factorial is the product of all the positive integers smaller than or equal to n. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Find the last two digits of this number. Okay, so 1 factorial is what is 1. It says last two digits. 2 factorial is what? 2. 2 times 3 factorial is 3 times 2 times 1, 6. 4 factorial is 4 times the previous one, 24. 5 factorial is what? 120. And because it considers squared, so look, 7, it is 5 factorial squared. If you consider that, it will be what? It will be 14400. And because it is multiple of 10, 6 factorial also have 0 something. And 6 factorial squared has 2 zeros. So from this part, from 5 factorial squared, they have no effect on last two digits. Because last two digits of all of them are 0. So we need to calculate only this part. So 1 squared plus 2 squared, because it says factorial squared, plus 6 squared plus 24 squared. We want to find last two digits of these numbers. 1 plus 4 plus 36. 24 squared is 576. Here it is what? 40. It is what? 41. And 1 plus 6, 7. 4 plus 7, 1. So last two digits is 17. Question number 15. How many positive integers with 10 digits a, b, c, d, e, f, g, h, I, j, all of which are different such that a plus j, b plus equals b plus I equals c plus h equals d plus g equals e plus f. So if I write a, b, c, d, e, f, g, h, I, j, a plus j equals b plus I equals c plus h equals d plus g equals e plus f, and all of them are different. So if I write the digits, I know some of which digits are 9, 0 and 9, 1 and 8, 2, 7, 3, 6, 4, 5. So we have these 10 digits, and because all of them are different, so each of we have a permutation of 0 to 9. But the only thing we should pay attention, a cannot be 0. So for solving this problem, one of the most important idea is to consider limited case first. It is so much important idea in Olympiad problems. So a has how many cases? A can be any of them except 0, 9 cases. So because a, then j, calculate. J has only one case. For example, we select one of them. And then for others, it is not important. B and I say, okay, one of them we've selected. You select 4 is left for B and I. 4 times 2. Why? Because you select one of these boxes and you say, okay, it can, for example, 2, 7, 2, 7, 7, 2. Or you can say B has 8 cases are left, and I will be 1. And the next one, for C and H, it will be what? 3 cases are left times 2 times. For D and G, it is 2 cases are left times 2, and for E and F, 1 case is left times 2. For example, 4, 5 or 5, 4. So it will be what? If we multiply, it will be 9 times, okay, 4 times 2, 8. 3 times 2, 6. It is 8. So it will be 9 times 8 times 6 times 8, 48. And it is 9, 64, 6, 32, 38. And it will be 36, 3, 75, 7, 34. Huafeng, problem number 16. Huafeng writes a sequence of 10 integers which may be negative, so that each number of the sequence starting from the third is equal to the sum of the two numbers that comes before it. The first number in the sequence is 10, 12, 10, 20, and the last one is 0. So here I can say how many numbers do we write? 10. So 1, 2, 3, 4, 5, 6, 8, 9. The last one. And choose number didn't exist 0, 6, 8, but here is some of them 120 plus 2a. Here is some of them 120, 120, 120 times 2 plus 2a plus a 3a. And this one will be 120 times 2 plus 1, 3 plus 2a, 3a, 5a. This one will be what? Sum of them. 120 times 2, 120 times 3, 120 times 5, plus 3a plus 5a, 8a. And this one is what? You should add up these two things. 538, 120 times 8, plus 8a, 5a, 13a. And this one is what? 120, if you factor 8 plus 5, 13, plus 8a plus 13a, 21a. Now it says, what's the sum of all terms? Now we know what the last term 0. 0 is what sum of these two terms. 120 times 8 plus 13, 21. 21 plus 13 is 34a. So here we can say 34a equals negative 1020 times 21. So if we divide both, we can divide both sides by, let me check, we can divide both sides by 34. A is negative. If you divide it by 34, it will be negative 30 times 21. It will be negative 360. Okay, now we add up all these numbers. It will be 1020 factor 1 plus 1 plus 1 again. 2 here, 3, 5, 2, 3, 5, plus 8 plus 13. And plus a, if you replace a with negative 630, 1a, 1a, 2a, it will be 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus 13 plus 21. Now, if we add up these numbers, so here in both of them is same 1, 1, 2, 13. So let's add up 13 plus 8, 21, 26, 29, 31, 32, 33. So because it is 33, so we say this times 34 minus 6, 30 times. It is what? This part is 33. 33 plus 21 is 5, 4. And we want to calculate this number. Okay, so let's check this one again. Okay, so yes, we've done all things correct. Let's just calculate. If we multiply these two numbers, 34, this, we don't consider 0, and at the end we will add that 4 to 8, 0, 4, 3 to 6, 0, 3, it will be 8, 6, 4, 3, it will be 3, 4, 6, 8. Minus, if you multiply these two numbers, 63, 54, 4, 3, 12, we have 1. 4, 6, 2, 5, 5, 3, 15, we have 1. It will be 31. It will be 2, 10, 3, 4, 3, 3, 4, 0, 2, 8 minus 2, 6, 6 minus 2, 6. And we should add 0 to each of them. So it will be 0, 6 minus 2, 6 minus 0, 4, and it will be, so the answer is 660. Question number 17. Maria has 5 blocks of weight 1, 2, 3, 4, and 5 kilogram. Respectively, she separates the blocks into 2 boxes in such a way that the weight of the first box is greater than the second box. And there are more blocks in the first box. Okay, so if I want to show it, it says what? Into 2 boxes in such a way that the weight of the first box is greater than the next box. And there are more blocks in the first box than the second box. So for example here 3, 2. In how many different ways can she do this? Okay, now we consider all cases. So here, if you have 5 weights, you have 1, 2, 3, 4, 5, and here we don't have anything. If we have 4 here, all of them are possible and okay, because sum of all 1, 2, 3, 4, 5 is 15. So if you divide into 2 blocks, for example, if we write also 1, 2, 3, 4, and the next part is 5, this one, it will be okay. So all cases, you can say 5, choose 4, or 5 cases are okay for this. The next one, you say, okay, if you have 3, if you want, you can write all of them. 1, 2, 4, 5, 3 here, for example, 1, 2, 3, 5, 4. You can write all of them. 2, last one, 2, 3, 4, 5, and 1. So we have 5 cases here and 3. If we have 3, let's start. 5, 4, 3, 1 and 2 is okay. The next one, you can select 5, 4. For example, suppose we have 5, 4, because the sum of them is 15. This one should be at least 8. 8, 7, at least it must be 8. So 5, 4 is good. 5, 4, 3, 5, 4, 2, 5, 4, 1, and you can check it is okay. The next one is if we have 5 and we don't have 4. 3, 5, 3, 8, it is okay. 5, 3, 1, and 5, 3, 2, 5, 3, 1, it is okay. And if we have 5, 2, 1, then again it will be okay. 3, 4, 7, 8, all of them are okay. If we don't have 5, if we have 4, if 4, 3, 2, it's okay. 2 plus 9. If we have 4, 3, 1, it will be okay. And if we have 4 and we don't have 3, then 4, 2, 1, then it will be bad, because some of them will be 7 and it's bad. And if you don't have 4, 3, 2, 1 is also bad. So 5 here, 1 here, 6, 7, 8, 9, 10, 11, 12. Okay, so let's count it again. 1, 2, 3, 4, 5, 6, 7, 8. 8 cases, 5 cases here, plus 1. 8 plus 5, 13, plus 1, 14. So the answer is 14. Okay, problem number 18. Rahman knows that his sock drawer contains 12 black socks, 10 blue socks, 8 gray socks, and 6 brown socks, all of the same shape and all mixed together. He is about to go on a trip and wants to take at least 2 pairs of matching socks of any 2 different colors. Since it is dark and he cannot tell the colors apart, he randomly grabs a bunch of socks. How many socks will he need to pack at least to be sure that he has 2 matching pairs of 2 different colors? So here we say, okay, it has 12 black socks, 12 here, and 10 here, 8, and 6. Okay. So we want to, it says at least to be sure. This be sure is important, because sometimes someone says, okay, at least 4, this 2, this 4. But it says be sure. It means in worst case, it has this condition. So if we select all these 12 colors and select one from here, one from here, one from here, it will be 12 plus 1 plus 1 plus 1, 15. And if he takes one more, 16, then, okay, if he has 16, then we say, okay, there are 2 groups that we have at least 2 from each of them, 2 different colors. Because if you don't have that, you have at most this 12, 1, 1, 1 from each of them, 15. So the answer is 16. Question number 19. Let ABCD be a convex quadrilateral such that, let me draw it. Okay, let ABCD be a convex quadrilateral such that BAD. I want to prove that we have this figure, equilateral triangle and square here. ABD. So in this case, if we consider, let's consider this figure, it's 60. It's 60 and it says what? BAD. Let's check. Okay, so let's change the names. Means here, move them. A, B, C, D. Now, if we consider D here, so we want to prove that this figure is exactly this. BAD, this figure. So I want to find the angles. Look here, if we consider this figure, okay, let's consider this figure, this side, and this is equal to this because it is 60, 60, all of them. It equals this, it equals this, it equals this, it equals this, equals this. So here we can say if it is x, it is x, it is 60, it is 30. So here we have this triangle. We can say this is equal to this. It is 30. Exterior angle is 30. So this plus this is 30. So it will be 15. It will be 15. Also, it will be 15. It will be 15 here. And now here it's 60 and here it is 30. So let's check the assumption of the problem. It says BAD. BAD, so it is 15. 15 is 60, so it is 30. BAD is 45. ADC. ADC, so because it is 30 and it is isosceles triangle AD by symmetry equals AC, you can say it is 75, it is 75. And here it says ADC, ACD. AB equals ACD. AB equals CD, yes, X equals 2, so you say, okay, it is 2. Find the length of BC. Okay, you can easily prove that it is a unique list figure, so it satisfies all the conditions here. So we have these things, BCD, ABCD. In geometry, there are around 50 important ideas. If you want to learn them, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Okay, we want to find length of BC here. So as you can see, here we proved AB is 2 here, BC is also x. So the answer of this problem is equal to 2. Question number 20. Amina has a quadratic equation, negative 2x squared plus bx plus c equals 0, such that b is positive. Bala takes Amina's equation and adds 1 to each of the coefficients so that Bala's equation is negative x squared. Look, negative 2 plus 1 is negative 1. Negative x squared b plus 1x. C changed to c plus 1 equals 0. Bala observed that the solutions to his equations are exactly the squares of the solutions to Amina's equation. Find the value of b. So let me tell you one important idea in these types of problems. Ax squared bx squared c equals 0. If it has roots alpha and beta, then you can say alpha plus beta is negative b over a. Alpha beta is c over a. There are some other important also idea. If you want to know them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, so the first equation that is for Amina is this. The second equation is negative x squared plus b plus 1x plus c plus 1 equals 0. So it is for Amina. It says Bala observed that the solution to his equation are exactly the square of the solutions to Amina's equation. So if you have this alpha beta, it is alpha squared and beta squared. Okay, so by this idea, we can say here alpha beta is c over a. So here it will be c over negative 2, which will be negative c over 2. Alpha plus beta is negative b over a, negative b. A here is negative 2, negative this over this will be b half. And the next one, alpha squared beta squared is c over a. Here it will be c plus 1 over this will be negative c plus 1. And alpha squared plus beta squared is what? I like here negative this over this, which will be b plus 1. Now, the problem says find the value of b, and b is positive here. Okay, so we want to find b. From here, alpha beta is negative c over 2. From these two equations, so alpha squared beta squared is negative c over 2 squared equals negative c plus 1. So here we can conclude c squared over 4 equals negative c minus 1. If we multiply both sides by 4, c squared is negative 4c minus 4. And then you can take all things to the left hand side, plus 4c plus 4 equals 0. So we can say c plus 2 squared is equal to 0 and c equals to negative 2. Now the next thing, I know that alpha plus beta squared minus 2 alpha beta is equal to alpha squared plus beta squared. Now we want to replace. Alpha plus beta is b half, so it is b half squared minus 2 times alpha beta is negative c over 2. Alpha squared plus beta squared is b plus 1. We know c is negative 2, so here it will be b squared over 4 minus 2 times this. 2 times this will be cancelled, minus minus plus plus c. Plus c, it will be negative 2 equals b plus 1. If we multiply both sides by 4, it will be b squared minus 8 equals 4b plus 4. And if we take all things to left hand side, it will be negative 4b minus 12 equals 0. Now we want to factorize. It will be b negative 6, b plus 2 equals 0. So b is 6 or b is negative 2. The problem says b is positive, so negative 2 contradiction. So the answer is b equals 6.